Okay, so we're going to start this unit with graphing what are called inequalities. So an inequality is a statement indicating that one quantity is not equal to another. So you can see the word equal in inequality, not equal. So if you're not equal to another quantity, then you must either be less than that quantity or greater than it. All right, there are four major inequalities. So the first one is the less than symbol. So if I read this from left to right, it says x is less than 5. So I'm going to think about numbers that are less than 5. So some possible numbers are, well, 4 is less than 5. 3 is. 0 is. I don't know, -8 is, right? Notice 5 is not less than 5. 5 is equal to it, so I can't put 5 on this list, but I can get really, really close to 5. Like I could put like 4.99, right? That's still less than 5, but it's really close. So to graph that, because I have to be really close to 5 and not actually hit it, I go to 5 and I put this open circle on it, indicating that that's like my boundary, but I don't want to include 5, so I'm not coloring it in. And the numbers less than it, like 4, 3, and 0, notice that they are over here to the left. So I draw an arrow going towards the left. All right, the next one, the symbol looks similar, but there's this extra little line. So it still is less than, but that little sign means now or equal to 5. Less than or equal to. So because I'm still less than it, I do have all the same numbers I had before. Again, I just picked random ones that were less than it. But it says, or I could be equal to it. So now 5 is allowed to be in this set. So the only difference when I graph it is, instead of leaving the circle open, I actually color it in to include the 5, and the numbers that are less than it are still to the left. All right, let's go to the next one. Now the arrow is pointing in the other direction, so this is the greater than symbol. X is greater than 5. All right, now I need numbers bigger than 5, so that would be like 6, 7, 11, I don't know, 100, right? Again, it says it has to be greater than 5. It doesn't say I can be equal to, so I'm not going to put 5 on this list, but I can get really close to 5. I could do like 5.1, right? Really close to 5, but still bigger than it. So because I'm not including 5, I get that open circle again. But this time, 6 and 7, notice they're to the right of that, so my arrow is pointing this way. All right, last one in this set. Now it has that line underneath, which is that equal to. So X is greater than or equal to 5. So again, because it's greater than, we'll grab all these same numbers as examples. But now, because I can be equal to 5, 5 gets to go on that list. So only difference is I color in that circle on the 5 to include it, but the numbers bigger than it are still to the right. Just a couple things I want to mention. If you have trouble remembering which symbol is less than and which symbol is greater than, one little way to remember this, if I draw these two symbols, ask yourself which one looks more like a capital L. To me, it's this one. There's your less than. Okay? So that's one way to remember it. The other thing I want to mention is that you got to get out of, like, if you were in elementary school and your teacher is saying things like, oh, the smaller number gobbles up the bigger number, or whatever phrase they use. It's going to be really tricky to use when you have a variable. So you want to get in the habit of knowing which symbol's which and reading it like a book from left to right. So starting at the left, X, okay, that's the less than symbol, looks like an L. X is less than 5. You want to get used to reading it horizontally like that, especially when you get into high school. Okay, so let's summarize what our graphs look like. So in general, when we used a closed circle, that colored in circle, that was when we had those equal to symbols. So it was for the less than with the equal to or the greater than with the equal to. The open circles did not have the equal to's on them, so that was just the less than or the greater than. We shaded left. Our arrow went to the left for the less thans and left. They all start with L, nice to remember. So it's the less than symbol or the less than or equal to. So we shaded right then for the greater than symbols, greater than or greater than or equal to. All right, next type of problem here. It says interpret, again, we're gonna read it like a book, 10 is greater than X, and graph its solution set on a number line. Well, if 10 is greater than X, then X must be smaller than 10, right? So it could be something like 9 and 8 and 7, right? Dot, dot, dot. So when I go to graph this, first of all, when I graph, I like to put the number given to me in the middle. Then I increase by ones normally, 11, 12, 13. Then we go back by ones, 9, 8, 7. Doesn't have the equal to on it. So I have that open circle. But here's what's odd. So we said that if 10's bigger than X, then X must be something less than it, right? 9, 8, and 7, which go this way. Well, that's tricky to me because that looks like the greater than symbol, and didn't I just say the greater than symbol we shade to the right? But we just shaded to the left. So why that happened is because if you notice, the X is on the other side. In the first 4 we did, the X's were all on the left. Now that X is on the right. So personally, what I like to do before I graph these, instead of trying to make sense out of this, I'm like, ugh, X is on the wrong side. I'm just gonna switch this around and I'm gonna switch its symbol. It's showing greater than, I'm gonna go less than. Then I won't have trouble graphing. So just one other thing I want to ask says, why is this called a solution set? Well, it's a set because there's more than one number in it. So it's not like when we solve an equation where like, oh, X is 3, done, X equals 3. These are all numbers that are less than 10, 9, 8, 7. There's an infinite amount of numbers that are less than 10, so it's an entire set of numbers. All right, this little section is just to make sure we understand that it's a set of numbers and interpreting the inequality symbol correctly. Which number is part of the solution set? X is less than 9. So you're asking yourself which number on this list is less than 9. Oh, 5 is. Notice 9 is not in this set because I have to be less than it. It does not say I can be equal to it. And these other ones are bigger. 2, which number is not part of the set X is greater than or equal to 54? All right, so 2,000, is that greater than or equal to 54? Yep. 58, yes it is. Is 54 greater than or equal to 54? Sure is, it's equal to it, right? But 45 is less than it, so that's the no. 3, which number is part of the solution set of 3 is less than x? Ugh, there's that thing where that x is on the wrong side. I don't like it. We're just gonna switch it around. It says less than, I'm changing it to greater than. Now it's gonna be easier to do. Which number is part of x is greater than 3? So look for a number bigger than 3. That would be 8. Number 4, which number is not part of the set x is less than or equal to -7? Now, remember, careful with negative numbers. They're kind of opposite those positives. To be less than a negative number, you're getting colder and colder and colder. That's a big negative number, okay? So if I don't want a big negative number, I'm looking for a smaller negative number or a positive. So -7, oh, that's equal to, so that one works. -2, is that colder than -7? No, it's not. That's the answer. These other two are colder or worse, however you want to think about it. All right, we're going to practice graphing together, and then you're going to have a sheet to do on your own. So at the top, as a reminder, we used a closed circle when it had the equal to's on it. We used the open circle when it didn't. We shaded left for the less thans, and we shaded right for the greater thans. All right, so again, number given to me, I like to put that in the middle. You don't have to, you can put it wherever you'd like. I like to count by ones, you can count by whatever you'd like. 9, 10, 11, 7, 6, 5. All right, let's start with open or closed. So check if it has the equal to on it or if it doesn't. Ours doesn't, so it's open. Now, shading left or right. Left is for the things that look like L's, right is for the other direction. Does that look like an L? Yes, it does, so going left. The other trick is to turn this into an arrow, and it's actually pointing the way your arrow should go. Nice little trick. All right, number 2, 24 goes in the middle, 25, 26, 27, 23, 22, 21. All right, so deciding if it's open or closed. It has the equal to on it. The equal to means I'm closing it. We're gonna color it in. I'll do that little trick. Let's stick that arrow in. It's pointing to the right, so let's go in that direction. All right, next one. -6 goes in the middle. All right, let's think about this. It's cold out. If we're gonna get colder, -7's even colder. -8, -9. Now we're getting warmer. -5, -4, -3. Has the equal to on it, so color it in. Turn this into an arrow. It's showing to the left. Number 4, 0 goes in the middle. If we're bigger than 0, we're at 1, 2, 3. If we're less than 0, now we're getting into the negatives. -1, -2, -3. Does it have the equal to on it? No, it doesn't. So we're going to leave that circle open. Turn this into an arrow. It's pointing to the right. All right, next example. Notice the x is on the wrong side. Let's change that right away. It says less than or equal to. It's turning into greater than or equal to. 12 in the middle. 13, 14, 15, 11, 10, 9. All right, it has the equal to on it, so we're coloring it in. Turning that into an arrow is showing going to the right. If you turn that guy into an arrow, it's pointing to the left. Don't do that. Make sure you switch it. Number 6, -2 in the middle. Getting colder out, it's -3 out, -4, -5. Now we're getting warmer, -1, 0, +1. There's no equal to on it, so open circle, turn it into an arrow, it's pointing to the left. All right, 50 in the middle, 51, 52, 53, 49, 48, 47. Does not have the equal to on it, so we're open. Arrow is going to the right. X is on the wrong side, switch it around. All right, so -17 in the middle. Colder is -18, -19, -20. Now we're getting warmer, -16, -15, -14. Has the equal to on it, so now we're coloring it in. Arrow is pointing to the left. All right, last two, they could give you a decimal or a fraction. That's okay. So let's put 7.4 in here. Depends how you want to count. Some people like to do 8.4, 9.4, 10.4. I'm going to count by 0.1, so like instead of 7.4, now I'm at 7.5, 7.6, 7.7, 7.3, 7.2, 7.1. It's not any harder. As long as you go by the same increments, you'll be fine. There's no equal to on it, so open circle. Turn that into an arrow. It's pointing to the left. All right, fraction. Let's put 5/8 in the middle. I think the easiest way is to keep the denominator the same and just increase or decrease your numerator. So if I increase, I'm now at 6/8, 7/8, 8/8. Well, if I have 8/8, I now have a whole. You could write 8/8, no one would take off for that. We're going backwards, 4/8, 3/8, 2/8. All right, has the equal to on it, so color it in. Arrow is pointing to the right. And that's it. The next sheet's for you to try on your own, and your teacher has the answer key for you to check it.